everyone. We are, you might not believe this, a Calculus 3 class. And what we are meant to be doing today is finishing off, hopefully, 11.5. We're looking at alternating series and absolute convergence. And yesterday, we explained to you what is absolute convergence. And as far as I can tell, there are 5 questions from the homework that deal with that. So essentially what you're going to be given in these questions here is you're going to be given a series, and your job is to pick one of the 3 things it could be. Could be divergent, and there's only one flavor of divergent, or it could be conditionally or absolutely convergent. So here is my version of question 12. And we are looking at -1 to the n minus 1. All over that guy, okay? Now I'm going to rewrite this guy. And the 9th root of n to the 4, I'm going to call it n to the 4/9. Are you comfortable with the fractional powers coming out of radicals? Right, are we good with that? Okay, let's look at this guy. If you test this fella out, essentially, don't we just need to, let's cut to the chase, don't we just need to know what that guy is? Can we assume that it is, that's always positive and it's decreasing? I know I should check it, but we don't have time for that. What does this guy get me? Well, can you tell me, what does that guy get you? What happens to 1 over infinity to the power of 4/9?
Well, it's a P series with P of less than 1.
Okay, but that,
so it converges.
What you said is correct, yes. What I was hoping for is that, right? So according to the alternating series test, would you agree this thing converges? Yeah?
Yes.
Right. Now, what kind of convergence? Well, we know that this version converges. Now we need to look at what that guy does, right? That's basically the same series, but everybody made positive, right? This is alternating. This is the same series. Everybody makes positive. Now, I think the P series things that we talked about is probably going to help here. Would you agree that this is a P series with P equal to 4/9? Wait a minute, isn't 4/9 less than or equal to 1? So what happens to a P series as a P value that's less than or equal to 1? Does it converge or diverge?
Diverges, right?
Diverges. What do we call a series that converges but doesn't when you make everybody positive? What's the name that we give to series that do that? Absolutely convergent, conditionally convergent. That's your choices.
Conditionally convergent.
That's it, conditionally convergent. Do you see how that process is going to work then? You're going to get a series, and your job is to find out which one of the 3 situations you're looking at. Is it divergent? Well, that's the end of it. But if it is convergent, and you'll be doing that because it's an alternating series, typically, you'll then have to decide whether it's conditionally convergent or absolutely convergent. So there's a little bit more work involved because of that. So the next fella in the list looks like this. This guy is an alternating series, and he is decreasing. And when you find the limit of that fella, the answer is 0. So that only tells me right now that this series converges. That's all I know. If I now turn it into this fella, It diverges. I'm telling you it diverges. Which means that this series is called conditionally convergent. That's the one you're going to choose. Now, I told you that diverges. We have about seven, yeah. I think we've got 6 or 7 tests right now. Which test could you use to prove to me that that diverges? Because you've got to prove it. I know in homework you just pick a dot, but in the test you need to prove it. Tell me how you could prove that. There's at least 2 ways I could do it.
Could you brute force it?
Well, if you do a brute force, you just get 1 over infinity and it doesn't really work. Brute force is not a method in itself. Brute force is what you do at the end of a method.
Could you do the comparison?
Yeah, and you'd compare it against a 1 over n or a 1 over 3n. Do a limit comparison test would work. If you want to do a comparison test, you'd have to do a bit more surgery on it. You could also do the integral test. All of those would work, and they'd all prove the same thing, that it diverges. But you gotta prove it. So I don't want to give you a test question where you just basically write the 3 lines I did. So it's do as I say, not as I do. You're going to have to prove it somewhere or the other, right? Now, if you want to do that as a limit comparison test, then this would be your original, untouched, and you'd compare it against, I don't know, say that guy, or actually you can just compare it against a 1 over n, a p series. That would work. If you wanted to do it a slightly different way, couldn't you take this guy and say that he is bigger, right, than that guy? Isn't 3n plus 1 smaller than 4n? So 1 over 3n plus 1 is bigger than 1 over 4n. And that guy, if you write him like that, he diverges, doesn't he? So it would work like that. Or if you did the integral test, wouldn't you be finding the integral from 1 to infinity of 1 over 3x plus 1 dx, which is a lot longer, but eventually would prove it. I don't care which method you prove something, as long as you prove it. Now, I've said that about 10 times. I can guarantee it. Somebody in this class is not going to prove it. And they're going to be really annoyed when they get big fat 0 or almost.
Will you put that
0.
back up on the screen for just a second because my video is really slow.
Here we go. So it's your commitment, right? You can't turn around and say, oh, I never knew you had to prove things. If you tell me you never knew you had to prove things, what that's telling me is that you haven't been listening to me for the last 2 weeks. Would you agree? I've said it tons of times, even although I haven't done it myself. I've said, you've got to prove these things, right? You've got to do a method. It can't just be say, yeah, it's convergent. And I can tell because I'm looking at it. Well, I can do that too, but still not a proof. Let's try next fella. I got this fella. We're skipping things for time purposes. This is an alternating series. Agreed? So I should prove that 1 over n cubed plus 4 is positive and decreasing, but I'm telling you that it is, and pretend I've proved it. I'm only jumping to the end one. And so when we talk about brute force, that's just perfect, converges. Now, to tell what type of convergence, don't we have to do the version that is only positive now? Okay. Does 1 over n cubed plus 4 converge? One over n cubed plus 4. Does it converge? It does. Isn't it to compare it to a 1 over n cubed? Do a comparison test on it. And so since this converges as well, the original series is absolutely convergent. Try 15. Two plus 3 times the sine of n over n is a 6. That isn't even an alternating series, so what the heck is going on? He says to himself. Oh, I know. Okay, we're good. If I can prove that that's convergent, then I'm actually indirectly also proving that it's absolutely convergent. Now, the reason you might say, well, how can I get away with that? I know that this sine n goes positive and negative all the time, and I realize that could be an issue. But would you agree that it's not huge? The worst it can be is 3, and on the other side, the worst it can be is -3, right? So I'm kind of treating that as a special situation. So I want to know what this does. Any suggestions for how I could test that it converges and therefore absolutely converges? Which of all the tests that you've done would you use on an ugly guy like that?
I used the comparison test, but I'm not sure if that's the right one.
Yeah, I would use it as well. You can't really do the ratio comparison test because you end up with some really ugly looking fraction. Now, all I need to do then is say, if that's going to converge, which I believe it is, because doesn't it behave like a 1 over n to the 6, right? A p-series. Then I just need to figure out how to make this guy, right? Oops, there's a 3 there, sorry. How to make this guy work with that guy. Would you agree that it's always going to be less than 5? 2 plus 3 sine. Isn't 2 plus 3 sine always going to be less than 5? Agreed? Now, what do you know about that guy? It's p-series, p equals 6, which is bigger than 1, it converges. And since that converges and this is smaller, doesn't this converge? And so we're finished. So as strange as that question looked like, it was actually easier to do as far as workload goes, because I only needed to show that one series converged, because when you make it positive, which is what I'm assuming here, that it was positive all the time, it works fine. Here is a trick question for you. 16. That is an alternating series. That's why it's a trick question. The cosine of n pi. When you plug in 1, you get the cosine of pi. When you plug in 2, you get the cosine of 2 pi. When you plug in 3, of course, you'll get the cosine of 3 pi. What is the cosine of pi?
-1.
Okay, what's the cosine of 2 pi?
1.
Cosine of 3 pi. You might just pardon -1, okay. So this guy up here is that fella. So this one is actually just an alternating series. Now, when you write it like that, can't you check for convergence? And then you should be able to prove, I believe it's conditionally convergent. So that's the first part of today, kind of zoomed through a little bit, but we got it done. And we are going to look now at estimating the value of a convergent series. Alternating series, I should say. Okay. Suppose I take n equals 1 of -1 to the n plus 1 over n squared. Can we imagine that it's already been checked that it converges and that's done? And what we're interested now is two types of questions. The first one is, what would be the error if I used S3 to estimate this fella, the sum of the series? So that's our first kind of question. What error, if I used S3, say, to estimate the sum, right? How good an estimate would it be? And step 2 is, or question 2 is, how many terms for, say, Sn to get an accuracy of 0.0001. So in other words, how many terms will I need to add so that the partial sum Sn would be within 0.0001 of the answer? So that's our two kinds of questions that we're going to deal with. Right, so for this series here then, what would happen if I'd used S3? Well, S3 would be, well, if you plug in 1, you get 1 over 1 squared. Take away 1 over 2 squared plus 1 over 3 squared. Would you agree that's S3, the third partial sum, what you get when you add up the first 3 terms? So I'll do that on my calculator because it's 1, take away a quarter plus 1/9. And the answer I get is 0.86 and a lot of ones. But I want to know what error I get. For an alternating series, the error in using S3 is the value of A4. It's the value of the 4th term, right? That's the first term, that's the second term, that's the third term. Isn't the 4th term going to be plus or minus 1 over 4 squared, which is 1/16, or plus or minus 1 divided by 16. The error is going to be 0.0625. So for this series here, which we already know converges to something, we know that it converges to 0.861 plus or minus 0.0625. So not only do we know what it converges to, don't we have a really nice way of telling you what it converges to, what number? So it could be, I guess, as big as 0.92, and it could be as little as 0.8, roughly, very roughly. Are you happy with how you answer the question, what's the error if I used S5? Right, if I said, what's the error if I used S5, wouldn't you pick 1 over 6 squared? What's the error if I used S100? Wouldn't you pick 1 over 101 squared in this question? So that's stage 1 done. Let's do it. How many terms then to get this accuracy? Then we know that an plus 1, right, the next term, is 1 over oops, is 1 over n plus 1 squared, and it has to equal 0.0001. So basically, we just need to solve when does this guy equal that number, because this guy represents our error, and n will tell us how many terms. I would solve it by doing this little trick. Check it out. If you make it a reciprocal of itself, you get 10,000. And won't that make n plus 1 the square root of 10,000? And we know it's positive number, so I don't need to do the negative version of that answer. And that ends up being, oh, I should have thought that through. And so won't that make it 99? So you need 99 terms to get an accuracy of 0.0001. And that's essentially the two main kinds of questions that you're going to deal with. If I use S5, what kind of error would I expect? Or how many terms do I need to get the accuracy to within 0.01? One of these. N equals 1 to infinity. Let's do negative 1 to the n over n to the 4. Okay, question 1, question 2. Question 1. What is the error if we use, okay, what partial sum do you want? Don't say 100 because I'm not going to do it. Pick a very small number, less than 6. What kind of partials?
3.
3, why not? Did I use 3 the last time? Okay, I'm changing it. How about 4, just to be different? Right. Do you think only using the first 4 terms of this convergence series is going to get you anywhere near the final answer? Or do you think it's still going to be pretty inaccurate? Right, only using 4 terms. You know, how close to reality could that be? Well, S4 then is, well, it's negative 1 over 1 to the 4 plus 1 over 2 to the 4. Take away 1 over 3 to the 4. Add 1 over 4 to the 4. You happy about S4? And this is why we have calculators. So it's going to be negative 1 plus 1 divided by 2 to the power of 4. Take away 1 divided by 3 to the power of 4. Don't be surprised that this answer is going to be negative. Plus 1 divided by 4 to the power of 4. And the answer I get is negative 0.945939. That's probably overkill, would you agree? So my estimate is that. But won't the error be the 5th term? And the 5th term, and we don't care about the, you know, the minus part, is basically going to be that guy. And 1 divided by 5 to the power of 4 is 0.0016. So I'm going to make the conclusion that this series, S, right, it adds up to negative 0.9459, give or take 0.0016. And if you want a little bit more accuracy, negative 0.9459, take away 0.0016, means that it's negative 0.9475 up to negative 0.0016. 9459, add 0.0016 up to negative 0.9443. Would you agree that we're pretty sure that the answer to this series, if you added them all up, is somewhere around about negative 0.94? Can you agree that it's somewhere 943, 9475? That's pretty good, isn't it, considering we only use 4 terms that we already know? Why do you think in this case the answer's so good, even with 4 terms?
Because it's it's 1 over n to the 4th power. The larger the power on the bottom, the larger the 5th term, or the smaller the 5th term is going to be, and the lesser error is, because you're adding up smaller terms at the end.
Agreed. Would you agree that 1 over n to the 4 gets small really, really quickly? Right? I mean, for instance, see when you got to the 10th term, isn't the answer 1 over 10,000? It's already 4 decimal places, right? 0.0001. So that one would converge really, really quickly. Right. Now, let's do a second part to this story. How many terms do you need? Right, that kind of question, right? So essentially, find n, that's how many terms you need to get an error. Pick any number you like, any nice small number. And I don't care if it's ridiculously small or medium small or just weird. Just pick something small. So how many terms do you need to get an error of 0. Come on, somebody volunteer it. You think this is a trick question. That's why you're not answering. It's not a trick question. Just give me a little number.
It's got to be n of infinity then.
Well, we're not going to go that small. So just give me a 0.001 or something. That kind of thing. That's all I'm looking for.
Oh, 0.005.
Okay. How many terms do you need, do you think? You could do that in 6. You know, that kind of show I can name that in 4, right? What do you think? 6 terms? Maybe 20 terms? Got a gut feeling? Let's find out. En plus 1, which is essentially the error, right, has to equal 0.005. Now, the formula that we've got is n to the 4, so en plus 1 is that guy. If you turn both of them upside down, n plus 1 to the 4 ends up being that guy. 1 divided by 0.005 ends up being 200. If you take the 4th root of 200, that's a quick way of doing the 4th root, you get 3.76. If you take 1 away from it, you get 2.76. Now, you can't get decimal number of terms, so it has to be a whole number. And would you agree that 3 terms? So if you want to know what this adds up to, and you're happy with your answer being within plus or minus 0.005, you need only to use 3 terms. Now, here's a little hiccup, just a tiny one. Can you imagine in a different question, I got 11.7. I think everybody here would say, yeah, that's pretty obvious. You have to round up, right? 12 terms. But here's the hiccup. Suppose n ended up being 11.2. That could happen as well, couldn't it? What do you round it off to?
$12.
Yes. Why do you round up in every case? There's a kind of reason behind why you always should round up. And remember, we're
Because-
talking about error here. Yeah, Molly?
Because you need like a complete number to like finish it. But
Right.
you can't have like a little bit left over. So you need to round up.
Right. So to guarantee the error, don't you have to err on the side of safety? So you always round up. That's essentially it, yeah. Do you feel comfortable about these questions where if I give you an alternating series that you can find the error if you use S4, or you can find the number of terms you would need to get any given accuracy? Are you comfortable about the two versions of the question? We've done two of them. But is that method seem consistent? Right. So let's look at what they look like when you do them inside. When you do them inside the homework. So here we go. Okay, so they do a little bit more work, but that's fine. Consider the following series, right? It's an alternating series, not unlike my n to the 4 that I did a few moments ago. Oh, they want a really good error, right? Do you see how small they want the error to be? Now, show that the series is convergent. Well, we know it's convergent. Since the series is a alternating series, would you agree that's an alternating series? I had to read them, right? Which conditions need to be shown? Right, if you're an alternating series, doesn't that guy have to have a limit of 0? But doesn't it also have to decrease? Now, which one of these guys is telling me that the series is decreasing? Which one of these three boxes that are left is saying that the next term is bigger, is less, I should say, than the one that came before? Because the way they've written it is not English. It's mathematical, but it means it's decreasing.
The last one.
Yeah. Think of that as the n plus is one term, right? The next term is less than the previous. You see, they use that n plus 1 trick. And then it goes on and asks you for how many terms. So if you wanted to solve this, won't you take this guy here and make him equal to that guy? Because it's easy to solve an equals, isn't it, than an inequality. The math is the same, it just looks nicer. And remember to round up, just for safety. Right, in question 18, identify the b to the n. Right, in this case, it's a fraction. It's going to have a 1 on the top, and on the bottom, it's going to be n squared. Excuse me. Followed by a 3 to the n. So far, so good. Would you agree this is an alternating series, and that's the bn? Wouldn't the answer to this be 0? Can you just do brute force, right? Just plug in infinity, it goes 0, right? Since the limit of bn is equal to 0, and that this guy is decreasing, for all values of n, the series converges. See, that's us just, they're trying to get you to do a little bit of working, even if it's not much. And then it's a how many terms do you need to get the accuracy? Oh, I better show you that one. Right, we need to solve the following problem. And I'm going to show you a lovely little trick. You're going to like this trick. Trust me, you're going to like this trick. Now, according to the formula, this fella is 1 over n plus 1 squared, 3 to the power of n plus 1, and it has to equal that guy. Now, in the ones that I've done before, didn't I do it algebraically because it wasn't too hard? Would you agree that this guy is not going to be your friend? Right. Now, I will do one thing. I will do the turn me upside down thing. The reason I do that is I just don't like fractions, and they cause more trouble than they're worth. So I try and avoid fractions. And so I have got 1 divided by 0.0005, and I get this other. So we are trying to solve that guy. First things first, you can't solve that algebraically. Can you just trust me? There isn't any square root of both sides that's going to save you. But all I'm really interested in is what n is, right? Any way I can make it happen. So how about going to our calculator and plugging in y equals, well, let's get all the other stuff out of the way, is going to become brackets x plus 1 squared, followed by 3 to the power of, I guess I'll need brackets to be sure, x plus 1. And then in y2, put 2000. Go to window. Make sure you start at least a nice number. 0 is good. I don't know what number I want to pick here. I want to pick 5. And then I'll do a zoom to fit. If it doesn't break it. Okay, there's my curve. And there's my guy. Do you see my straight line meeting my curve? Can you see it right there? Now, I could do intersection. I can find that point. I'm going to do second calc. I'm going to choose number 5, intersection. First curve, second curve, enter. And the answer I got is 3.27 and some stuff. So don't we just make n equals? Make n equal 4. You see, I just let the calculator figure out the solution. Do you like the shortcut? So when you're trying to solve for n, calculator take the strain. See what else we got. I'll just talk through the last few because basically we should be able to finish the section today. Right. If you're doing question 19 and it wants your answer to 4 decimal places, aren't you going to do 1 over n plus 1 to the power of 9 equals, what decimal will you write down for 4 decimal places? Be careful here. It's not what you think. If you want to be correct to 4 decimal places, right? So when you round it off, it's correct to 4 decimal places. You might think the answer is 0.0001. But it's not that. What is it? It's 0.00005. In other words, you move to the next digit and you do a 5. Because when you round off, isn't it the next digit that decides if you round up or down? So make sure it's 0.00005. Question 20. Oh, what a good question. Nothing like anything we've done. It's a puzzle question. That guy converges. What value does P need to be for that guy to converge?
It's got to be greater than -5.
And I agree. Do you want to explain to the people who don't know why that's the case?
You don't want n to the p to equal 0. That's how I figured it out.
Yeah. And don't you want it to at least have a bit of a P left over, like N to 0.1 or 0.2? So choosing to do it that way. Yeah. The last couple of questions I'm not talking about because it's one of those watch a video and do what it tells you. So we did it. I sent out reports today called Report 2. You all got them? Check them. Make sure they're accurate. Tell me about, I was here 4 days and you said it was 3, whatever. Last name, space, first name. Make sure we do that right now. And tomorrow we start our next section. That's it. Bye-bye. I am doing good at the timing. I'll hang about if there's any questions.
I do have a question for 19.
Uh-huh. Okay,
said
I'm
you-
looking at it.
You add all the terms up, and then I guess I just don't understand how you rounded that.
Okay, let me, in question 19, if we're talking about the one I believe we're talking about, it looks something like this. Let me get it on my white screen. Right. It's this guy, right? And they want it correct to 4 decimal places. Okay, so what's your question?
You were saying something, well, my version of it is a little different, but you were saying something
Okay.
of 0.0001.
Right, okay.
Yeah.
Okay, if you look at 4 decimal places, a lot of people think that you want this fella, right,
No.
to equal that. What I'm saying is that what you really should be looking for is that guy. And you might say, well, why is that rounding off to 4 decimal places when this is a decimal written to 4 decimal places? Well, take an example. Suppose I had the number 3.21 and I said, round that off to 1 decimal place. Where does the cutoff point happen? Well, that guy, all the way to that guy, right? And then rounding up, you get that guy, you get that guy, and you get that guy. But isn't the transition from rounding down to rounding up, isn't it on that guy? So to 1 decimal place, you are not trying to solve that. Aren't you trying to solve that?
Okay.
So when you round off to 2 decimal places, you need this fella to be 0.005. When you round off to 1 decimal place, you make this guy 0.05. I know that says 1, but that's not actually the guy that you should really be using, because the way we round off, it's actually the next digit that causes the rounding off.